So dbt is a tool. dbt-core is an open source tool that allows anyone to write pipelines using SQL and YAML. It's the transformation layer of ELT pipelines, and dbt-core is open source. The overall idea with the projects are you structured in folders, transformations in SQL files. Each of those SQL files maps to a table or a view. And then you define the relationship between models using Jinja templating via refs. So you can build very complex workflows, mainly using SQL and YAML. This is how the interface would look like for Jaffle Shop, where you have some seeds initially, so data that was loaded from CSV, and then each box represents a transformation. So to the left, your left, there are 3 seeds where you load data, and then to the right, 5 transformations, each representing a table. However, even though dbt is extremely popular among data practitioners, there are a few things that dbt-core itself doesn't solve. So the open source tool does not allow you to schedule jobs in production by itself. You would need to be using something else to schedule those jobs in production. It doesn't have scalable ways of extracting and loading data to the databases. If you have a team, it doesn't give you a centralized logging and alerting platform. And it does have a way of documenting projects, but it doesn't solve hosting that project. And all these problems, the creator of dbt-core tries to solve with their project called dbt Cloud, which is a proprietary platform. But many people want to remain using an open source tool to be able to accomplish all those things. And that's where Cosmos comes into place. So Cosmos is an open source project created by Astronomer, which aims to be the solution for people to run and orchestrate dbt pipelines in Airflow. It allows users to go from a dbt pipeline into an Airflow DAG with very little code. And then you can have the whole lineage of the dbt project into Airflow. This is how a Cosmos DAG looks like. The key part is you instantiate a dbt DAG or a dbt task group, and then you give the path to the dbt project. You can set a profile mapping in dbt define credentials to database via profiles file, and then Cosmos allows the users to automatically generate those profiles based on their Airflow connection, so you can keep your secrets in a single place. This DAG could be pointing to this simple project, or it could be pointing to a dbt project of 1,000 nodes. The DAG wouldn't change, but the topology changes, so it dynamically generates DAGs. From an adoption perspective, we have 20 million downloads every month. It is the most popular tool to run dbt-core in Airflow among the open source tools. And many people ask, but what about production usage? So the 3 of us work for Astronomer. We have hundreds of customers, and 20% of Astronomer customers use Cosmos in production, and we have millions of Cosmos tasks being run every month. This is only possible with the community, open source community involvement. At the moment, half of the Cosmos maintainers are actually from outside of Astronomer, and we had contribution from more than 144 community members, and this just keeps growing, which we are very grateful. However, even though we have a very high adoption, there are performance challenges. So last year, Pankaj, Koti, and I had the opportunity of speaking about some of the performance challenges people who use Cosmos were facing and how we were able to overcome. So as you can see, for a specific DAG, it was taking 8 seconds to be parsed. We managed to reduce to 2 seconds, so to 1/4. And many other metrics we also managed to improve. And this was part of our last year's talk. However, performance remains a challenge from many perspectives. And we recently were analyzing further how we could improve further the performance. And one thing we realized was many people say, well, I can just use dbt CLI, run my pipeline locally, and that's much faster than running in Airflow. And I said, oh no, but how bad is that? So we started trying to understand why things were so bad. And then we attempted to run the same pipeline, using a single dbt command, or breaking down the pipeline in 3, or then breaking down into 13 commands and analyzing the performance for each of those things. And we realized that as much as you break the dbt project into multiple commands, the execution time increases significantly because dbt will have to reparse the project multiple times, and it won't be able to leverage threads. That's how the transformations happen when you're using the CLI, because you are having one process to execute to each of those. And in Cosmos, what happens by default is we are actually splitting each dbt model or each transformation to be run as an Airflow task. So users are having to pay this cost of 61 seconds instead of 17. And this is an example of Cosmos DAG where we're doing exactly this, the default behavior. And then it is possible to reduce the granularity in Cosmos, so you have less dbt commands, but then you have less granularity in the view, and you don't have the ability to retry if a specific model failed. You don't see the lineage in the Airflow UI, so it's much more limited how much you interact. And the performance can be as close as running a single dbt command, but then all the lineage is gone. So even though Cosmos performance, it's proportional to the amount of dbt commands, and it's proportional to dbt-core and the recently released dbt fusion, we did think we can do better than this. Would there be ways of running more efficiently dbt in Airflow? So we really want to be able to have the fine-grained visualization, so people can have the lineage within Airflow UI. You can see the transformation, the SQL associated to each transformation, and give users the ability to retry, but without paying the cost of taking more than 4 times the runtime of a pipeline. So during this talk, we will be discussing 2 approaches we implemented in Cosmos to try to solve this problem. And I will be inviting Pankaj Singh to talk about the first of this approach. Thank you.
Hi, I'm Pankaj Singh. I work for Astronomer and I am Apache Airflow committer. So to understand Airflow deferrable operator, you'll have to understand the pool in Apache Airflow. So let's say you have a deployment and your pool size is 4. That means you can run maximum 4 tasks in your deployment. So in Apache Airflow, deferrable operator is a special type of operator that can pause its execution and defer. Once it deferred, it's free up your worker slot so that other tasks can use it. And that's how it optimizes the resources. On the execution mode, so Cosmos provide you a couple of execution mode. You can think it's of a like how and where you want to run dbt command if you are using Cosmos with Apache Airflow. So for example, in local execution mode, so you run dbt command on your worker node. In case of virtual environment, you isolate your dbt command running in a virtual environment mode. Similarly, in Kubernetes execution mode, you run it in a Kubernetes pod. In case of Airflow deferrable operator, so if you see here on the right-hand side, for each task without deferrable mode or async execution mode, so we run dbt command for each task. For example, for seed or for stage customers model. And we know from Tatiana just pointed out, like running multiple command has some cost. So Airflow async take a approach. What if we do not have to generate the, basically we do not have to run the dbt command on each node. So Airflow async operator provide you a setup task, which is a sort of like a head task you can call or a start task of your workflow. And it generate a pre-compiled SQL that can be understood by upstream database like BigQuery or Snowflake or Databricks. And since now you have raw SQL, the downstream task, particularly model, can take and execute it. We use deferrable operator to run those transformations, and that's why this is Airflow async execution mode. To understand more about how the setup task has been designed, so you need to think of the process how we run actually dbt command. So when you run dbt command, you run it against some adapter, maybe BigQuery. So dbt semantic layer provide a way to write model seed, etc., that cannot be understood directly by BigQuery or Snowflake. So dbt internally translate those model into SQL that can be eventually executed into the upstream database. So that is the normal flow. The top one, you can see the cross. In async execution mode, we modify uh, the adapter at runtime. That means we just run dbt command till the point we can get raw SQL, and we do not execute into upstream database. We just get the SQL and then upload those SQL into Airflow XCOM. And now, since we have a raw SQL that can be understood by upstream database, uh, now our downstream operator just can use those SQL and submit directly into the your database. At the moment, we have support for BigQuery, and for that, we internally use BigQuery insert job operator, which is, of course, in deferrable mode. So we save the resources, time, and also the task throughput here. This is how your workflow graph view look at the end. You can see you have a setup task, a tear down task, and the your actual workflow, which is for a dbt project. So we did run some performance, and you can see with the dbt run command, it took around 13 minutes. With the local execution mode, Cosmos, of course, 11 minutes, and then execution mode, Airflow async. Before 11 1.11 alpha, it took 11 minutes, and now on our latest pre-release, it take around 7 minutes. Just keep in mind, like we run dbt command with thread count 8, and also for the other data, like we have Airflow instance such that we can run a task at a time. We use a custom model. The project is now in open source. Maybe we can share, you can find link here also. So which is around 120 model, and those model mostly are in parallel to we can get some real feel. Like any like features, it come with some pro and cons. So you can see if with local execution mode, the deferrable operator or deferrable Airflow async execution mode now perform 36% better in terms of time. You are just running single dbt command, which of course count you in improvement of your overall performance. Since we are using deferrable operator, which is non-blocking, better CPU allocation, and saving some money. Cons, it support only for dbt model at the moment at least. Uh, Currently support only BigQuery. Why BigQuery? Earlier we saw like we modify or mock dbt adapter at runtime. So if you want to support for other database, you'll have to do similar for, let's say, Databricks or the other database. So, and of course, since we are generating the pre-compiled SQL and not running it in upstream database in setup task, so it cannot be done for like all type of project. If your project has some dependency such a way that we cannot generate pre-compiled SQL, in that case, this approach may not work. Also, dbt recently released Fusion. So with dbt Fusion, this will not work because that is in Rust. So we'll have to explore how to mock that. Next step, uh, available since Cosmos 1.9 for BigQuery. We have done significant improvement in 1.11. We'll release it soon. We value your feedback, and it's a lot for us. So any feedback are more than welcome. We have introduced some telemetry to collect data so that we can make better decision how to proceed here. We love contribution. We have already more than 100 contributor. You can be next. Yeah, thank you, Pankaj.
So more recently, we have been working on another execution mode. This is the strategy 2 that we are going to talk here. It's called Watcher. Similar to the Airflow async mode, the design is similar here. We also have a setup task in the beginning. The difference is like we mocked the dbt adapter in the Airflow async mode. Over here, we are not doing any mocking, but allowing dbt to run the project based on your selections to its entirety. So that happens in the setup task. We run a dbt build command, and the catch here is that along with running the dbt build command, we are also pushing to XCOM the statuses of each of the individual model seeds or any of the resources that get run. And those XCOMs, the downstream tasks that you see, so apologies, the name of the operators are not clear, but those are watcher operators. So they are essentially sensor tasks, Airflow sensor tasks. What they are doing is they are pulling the XCOM status of the corresponding model or seed or whatever the resource is that is getting pushed by the setup task. We are calling it as producer and consumer tasks. So yes, that is how the design looks like. How do we achieve it? So to achieve this, we are actually leveraging dbt-core's event manager. So they allow us to register callbacks while running dbt commands. So like you see, there is an example of this callback. Similar to this, we also register callbacks in the producer task that gets events, model completion events. So the events are called node status events. So for each of the node status event, we check what type it is and register a corresponding XCOP along with the resource ID. So yeah, so there's a link there. You can read more about it on the dbt docs page. And this has shown tremendous improvements in the runtime execution. Last year, like in the talk that Tatiana suggested, we have made tremendous improvements in the DAG parsing process. Now here is an improvement in the DAG execution time frame, both in the async and the watcher approach. So when we ran dbt build command in the CLI with the default 4 thread counts, it took like 6 to 7 minutes on a project. So down there you see a project from Google. So it's a open source dbt project from Google called FHIR dbt analytics project, and we have benchmarked on this number. The good thing about this execution mode is we are now able to leverage threads. If you have tried already Cosmos in the local execution mode, so what happens there is in each of the tasks, you submit a run command for a specific model. And even if you have threads count set to more than one, it won't be used because you're running only one model. But in this producer task, if you increase the thread counts, if you can run your models in parallel and have enough CPU cores, that means your models would be run in parallel. So these are the comparison numbers, like in the initial slide that Tatiana mentioned, like if we run dbt run on individual models one by one, it takes like 30 minutes on the same project. And in execution mode local, since we can run some tasks in parallel using Airflow, it takes about 10 to 15 minutes. But the good part is this, as and when you can increase the thread counts, you can see like there is a tremendous increase in the diagram duration. So when you have threads count set to 16, the same project finishes in 2 minutes. So almost down from 30 to 2, and from 10 to 15 in Airflow to 2 minutes. So that's the improvement. We also tested this on Astro. So when we tested on Astro's A10 instance, it took us 5 minutes when we set the thread count to 8. Coming to the pros and cons, so the DAG run time we observed in the case of Google project down to 1/5 of the original time. You would have your run results, a unified run results for your entire dbt project getting pushed to XCOM. If you have any pre-hook, post-hooks, that would be supported by default. For now, the Airflow async mode is supported only for BigQuery. And if you want to add more, the contributions can come, and we'll have to have specific contributions for each of the adapters. But since here we rely on the dbt command itself, we don't need to have any warehouse specific implementation. So all the warehouses that Cosmos supports would be supported. Coming to the limitations, since the sensors currently occupy worker slots, the slots would be blocked while they are sensing. That's the problem. Retries have the same performance as execution mode local, meaning like we allow retries in this execution mode, but then you would hit, if a specific model failed using the Airflow UI, you could try a specific task to be retried. There's no way to parallelize all failed tasks. Of course, you can do clear all the downstream tasks, and that would happen, but it's like the threads won't play a role when you retry. One of the important thing is to leverage the callbacks. You need dbt runner, and for that, you need to have dbt and Airflow installed in the same virtual environment. We have a fallback wherein if you don't have it in the same environment, you can still leverage. But the point here is that to achieve that, we push the run results at the end of the dbt build command, and we need to rely on the run results in the sensor task. That means until the producer task finishes, you can't actually sense. Still, we are working on adding support to other Cosmos features like Cosmos callbacks, data sets, and open lineage events. So what are the next steps? So like I said, we are working recently on this. We already ran a successful POC in the month of August. It has been, we are working on productionizing it, and by the end of this month, we'll have a stable release out, 1.11. But if you're willing to try it out, we already have an alpha out, alpha 6 of 1.11. This task is on deferrable, so this talk is on deferrable mode. So we are working on making the sensors deferrable in an upcoming release. We of course need feedback. So if we would invite all of you to try out Cosmos, these execution modes, and feedback is very much appreciated. And this is an open source project, so we love contributions. So if you're, you can check using this label, so open issues on the execution watcher mode. And if you have the time and are willing to contribute, we always welcome that. Thank you.
So, some takeaways that we would like everyone to leave the session knowing. It's very clear that running a single dbt command is more efficient than decomposing a pipeline into multiple dbt commands. When we implemented the deferrable support, we were able to reduce the DAG runtime by 36%. However, there are circumstances where you can't just compile the SQL ahead, depending on how complex your dbt project is. And to overcome this, we implemented the Watcher approach, which allowed to reduce the DAG runtime up to 80%. And this may even be higher depending on the dbt project you have in place. All this work is being done in open source, and we would love feedback from the community and support to make sure we're going the right direction. We want to make Airflow the best place to productionize dbt pipelines. And we would love your support on testing, discussing, implementing. We really believe that the core thing of Cosmos is to be built by the community for the community. And that's why we have 20 million downloads every month. We recently had a colleague, Tamara, publishing a book on dbt in Airflow. It is an impressive document of almost 100 pages. It is free to download. So please feel free to download. If you have any issues with the link, reach out to us and we can make sure you have the PDF. So do have a look. It's really, really well written. If you didn't have a chance, answer the Airflow survey, please. And thank you very much.